You notice we're still in lesson 4.6. And sometimes the equation is given to us in another form, not that friendly form called slope-intercept form, which is nice for graphing. So what we're going to learn today is how can we take an equation that's not in slope-intercept form and put it in that form, so that then we can get the slope from it and the y-intercept, which will then help us graph it. So we have this equation right here. Why don't you circle it so you can see what we're doing here. We're taking that equation, 2x plus 6y equals 12. We're supposed to write that in slope-intercept form and then graph a line. How do we know when it's in slope-intercept form? What does it look like? Right?
Y is by itself.
The y is by itself. Well, in this case, 2x plus 6y equals 12. That y is not by itself yet, is it? So our first step is going to be, get that y by itself. Solve it for y. That's what they're saying. Get y alone. So we look at the side that y is on, and we say, what's happening on that side? First of all, we could read addition backwards, so 2x is being added to 6y, isn't it? So what can we do here?
Y by 6.
No, we don't want to divide by 6 yet. That wouldn't be our first move. Let's take care of the addition or subtraction maybe first. Ariel?
Subtract 2.
Subtract 2x. It's not just subtract 2, it's subtract 2x, isn't it? Okay, so we're going to take 2x away from both sides. Now, we're not going to get a numerical answer here, you guys. We're going to just rearrange this equation. That's all that's going to happen. So now, the 6y is alone, and it's 12 subtract 2x. But we can't really take 2x away from 12, because that 12 is not x's. Cameron?
Can't we make it add the opposite and 2x and then put it in front of the
Yeah, we can do that. We can change this to add the opposite, add a negative 2x. And then he said, can't we rearrange it? In other words, can't that negative 2x and that 12 trade places? They can once it's addition. And then we have one more step to do. Trey?
Divide by 6.
Divide by 6. So we're going to take every piece and divide it by 6. Every piece has to be divided by 6. And I wrote so big I ran out of room. Okay, what happens here? These 6's cancel. And we're going to end up with, I'm going to have to move down here, y equals, what's a negative divided by a positive over here? And by negative 2x divided by 6. Would that be a negative or a positive?
Negative.
That'd be a negative. 2, 6, is that 3? No, because the 6 is downstairs, not upstairs. So is 6 going to go into 2 nicely? No, what do we do when it doesn't? Josh? Yeah, it's 1/3. We can make that 2, 6 into 1/3. And that x is going to be right behind it. So we have a negative 1/3 x plus what? 2. Yeah, there's our equation right there. So step 1 is done. Step 1 was solve it for y. Get y by itself. Well, why did we go through all that work? Because we have to graph this. And if we were going to graph it, it sure would be nice if we knew where to start and what kind of slope we could use to help us get other points. So what is the slope of this line? Negative 1/3. Let's do our rise over run thing. Remember rise over run? Let's write that down. Rise over run. We have 2 different ways we could do it. We could give the negative sign to the 1, which would mean we'd go down and right. It's one of our choices. Or, and, we can do what?
Make the 1 positive and then give a negative sign to the 3.
Yeah, make the 1 positive, give the negative sign to the 3 instead, which means we'll go up and left. Okay, what's our y-intercept? Where's our starting point? What's our
2.
y-intercept? It's 2. Okay, so we're ready to go practice, aren't we? Where are we gonna start?
2
2 on the
y-axis.
y-axis. Be careful, some people like to put that on the x-axis. Start on the y-axis always. I want you to use both forms of rise over run because we have room to. So get 2 more points graphed. Use your ruler that you kept at your desk as your straight edge to draw the line. Extending the line all the way through the graph with arrows at both ends. Okay. Pardon? Okay, so anybody have questions about this one? Okay, so let's go try one more together here. We have write 2x minus y equals 3 in slope-intercept form, then graph the line. Well, let's write that equation down here, because we're going to do step 1. So let's put step 1, y, no, not y, 2x minus y equals 3. Dakota, rename this equation for me, making it friendlier to work with.
It'd be y, like, in slope-intercept form?
Nope, nope, changing it to addition.
And it would be 3 y.
No. Changing the subtraction to add the,
Opposite,
so what would it look like, 2x plus?
negative y.
Thank you. In fact, can we slip a 1 in there also, you guys? Yeah, let's slip a 1 in there also. You can multiply by 1 and you don't change its value. So we can sneak that 1 in there. Okay. Now we are ready to get the y alone. We just, basically what we did is wrote the equation down and made it friendlier to work with. What are we going to do first? Cameron?
Subtract the 2x.
Yeah, we can read addition backwards. 2x is being added, so we have to subtract it. And so now we're going to have that negative 1y all by itself. And we're going to have 3 take away 2x. But we don't like it that way. We're going to change it to what?
Add the opposite.
Add the opposite. We're going to make it plus a negative 2x. Because then the 2x, the negative 2x and the 3 can trade places, can't they? So we're going to have negative 1y equals negative 2x plus 3. Starting to look more like slope-intercept form. It's getting closer. What do we do next?
Divide by negative 1y.
Well, we don't divide by negative 1y.
Negative 1.
Just by negative 1, don't we? Yeah, we just divide by negative 1 is all. Negative 1y gets divided by negative 1. Negative 2x gets divided by negative 1. And so does that 3 get divided by negative 1. And we should have our equation the way we want it now. What's a negative divided by a negative?
Positive.
Positive. And 2 divided by 1?
2.
2, so this is going to be a 2x, isn't it? What's a positive divided by a negative?
Negative.
Negative, and what's 3 divided by 1?
Negative.
Negative, so we have a negative 3, don't we? Okay. If they wanted us to write that in an, if we were going to put that in an, see that equation in answer machine, is that how we would see it though?
No.
Okay, it's kind of, we like it this way because it helps us be able to get the m and the b better, right? So let's do that first before we even try and clean it up. What is our m value?
2.
2, which helps us then do that rise over run thing. So what can we do for rise over run for this one? 2 over,
Negative 1.
no, 1. We can put anything over 1 if it doesn't have a downstairs. Trey?
Then, negative 2 over negative
Yeah, so this one would go up and right, or we could do -2 over -1, and then we would go down and left, wouldn't we? Okay, what's our starting point, our y-intercept?
-3.
-3, the number being added to the x's is always our starting point. Okay, so now let's go up there. Before we clean up this equation, let's just go get this graph, okay? So we put our starting point on and let's use both of our rises and runs. And make some points. I'm gonna go crazy and make about 5 of them all together. But you have to have, what's your minimum?
3.
3. If the graph holds at least 3, you put 3 on. So that was step 1. We didn't actually identify step 2 here. Let's go down here and say this is actually step 2, where we are identifying the slope and the y-intercept and graphing it coming up here. This is step 3, where we are actually graphing it, okay? But I still want to make sure that we understand that if they wanted us to write this equation in slope-intercept form, we actually already have, but chances are it wouldn't be in the answer bank the way we have it right now. We have it as y equals 2x plus -3. Is that how we're going to see it in an answer bank? Anybody know how we would see it instead? How would we see it instead? Stefan?
What it be y equals 2x minus 3?
Yeah, there we go. There's our equation in slope-intercept form cleaned up. That's how it would look. Okay, any questions? 'Cause this is what you're doing in your 7 problems of homework that you have. Actually, 6 problems, I'm sorry. Okay.